Good morning, all of you. Myself, Dr. Kapil Kumar Sharma. I am presenting a lecture number 4, that is quantum mechanics. Here, in last previous lecture, we have discussed in quantum mechanics like a Schrodinger wave equation. On the basis of Schrodinger equation, we can define the particle in a one-dimension box. Here, first of all, the content of this presentation like particle in a one infinitely deep potential well. We calculate also energy eigenvalue and we also calculate the wave function of the particle. Here, this diagram is represent, suppose we particle are considered in this limit 0 to a, and inside the potential v will be 0 and outside the potential will be infinite. Here, let us consider a particle are moving in a potential well within finite limit. We have a limit 0 to a. Here we want to calculate the energy eigenvalue and wave function of the particle within the limit via Schrodinger equation. We know that here the particle restrict to move only in one dimension. We can see these are only considered in one dimension between two potential barriers. Here if you see V is equal to 0 inside the limit and outside the limit V will be infinite. The height of the potential barrier goes to infinite at x is equal to 0 and x is equal to a. Here, one dimension region minus infinity to infinity, we have limit x can be divided into three categories in figure number 1. We have first condition, potential is infinite, that is x is greater than 0 or less than a, and it will be 0 inside the limit. Here we apply the boundary condition for this value in the region first and third, the time dependent Schrodinger equation. We know that these are Schrodinger equation, del square psi upon del x square plus 2m upon h cut square e minus u, psi will be 0. Here u is infinite because we are consider first and third region. U tends to infinity, then psi will be 0. That means there is no particle outside the limit because potential energy is 0. Boundary conditions show that outside the boundary wall, probability of density is 0. The particle is confined to the region second. Thus, we have Schrodinger time independent equation in the region S. Again, we apply because we know that d square psi upon dx square plus 2m upon h cut square e minus v psi is equal to 0, where u is the potential energy because u is 0. It is convenient to write the solution of above equation as the sum of sine and cosine rather than the sum of the exponential. Here d square psi upon dx square plus k square psi is equal to 0, where k is we can calculate in this area because this is equation become more complicated. So we solve this easy. We consider k is equal to 2m e upon h cut square की power half is a wave number. Here we apply the boundary condition. We solution of this equation by mathematical operator psi is equal to a sin kx plus b cos kx is this equation number 7. And here if x is equal to 0, because we have a two limit boundary condition, x is equal to 0 and x is equal to a. So psi second region a put sin 0 0 plus b will be 0. Now in second region the equation becomes psi a sin kx, yeah, like ka is equal to 0. Only apply this boundary condition if x is equal to a. Now we get a is equal to 0, sin k is equal to a is not equal to 0, sin k is equal to 0. Because we know that sin 0 we can also represent sin n pi and n will be 1, 2, 3 and so on. But n is not equal to 0 because if n is 0, wave function will be 0. Here k is equal to n pi upon a, and again we rewrite the value like k is equal to 2m upon e into h e cross. Here we put the value and get the result. Now solve this equation and become en is equal to n square pi square h cut square if bracket open 2m into a square. These are the equation is energy eigenvalue that are very important, equation number 10. Above this equation, it is clear above expression the specific between the two consecutive energy level increase non-uniformly. Now equation become psi n a sin n pi x upon a. because we also calculate the normalizer factor. We have a limit 0 to a psi star, because probability is always calculated, will be real and positive. Then 0 to a, this value will become. Then solve this integration 0 to a 2 sine square n pi x upon a, because sine n is equal to a sine and this is also a sine. So we put the value of this value like the formula of cos 2a and solve this equation, and equation become a is equal to root 2 by a. Therefore, the eigen or wave function like becomes sin n is equal to under 2a by sin n pi x upon a. These are very important equation number 13. So we have two equation 10 and 13 are very important for numerical point of view. Here we see the normalizer wave function psi 1, psi 2, psi 2 with the probability density of psi 1, psi 2, psi 3 in this region. We have are shown figure. It is clear from the figure the wave function psi n may be positive or negative, where the psi n square is always positive, because we know that the probability is always 1. At the boundary condition, the wave function of probability density is 0. Here we understand the sum aspect. If n is equal to 0, now if you think about n is equal to 0, why n is not equal to 0? Then E naught is not allow energy band. The particle can never at be rest. The Schrodinger wave equation become d square psi upon dx square is equal to 0, whose solution is given like that. The two wave function, if x is equal to 0, x is equal to a, both a and b are arbitrary constant, must be 0, then will be 0. That is particle now found to in the state. Here include negative integer n is not equal, n is less than 0, produce no new, because change on the sign n is only in the sign of conversion, needing the same probability of this integration. These are very important expression for numerical. We calculate by this solution En is equal to n square pi square h cut square upon 2ma square. These are energy eigenvalue. But n is not equal to 0. N is not equal to 0. We have given the result. And wave function sin n is equal to 2 by a sin n pi x upon a. Here we sum representation. First of all, particle like a position. If particle are moving, n is equal to 1 for this condition. And these are this C point condition, these are D condition, these are E condition, these are F condition. These are probability of finding the certain spot in the box is determined by the squaring of the wave function. Here V tends to infinite and V tends to also infinite, because if n is equal to n, these are like a wave nature. If n equal to 2, these are the number of mode 2. If n is equal to 3, these are the number of mode 3. Here we putting this value and calculate also number of energy operator. These are important aspect, and we also calculate the different energy level in different position of the electron. Inside the box, particle n is equal to 1 for like the limit, for n is x is equal to 0, n is equal to a, we can put the value and different parameter. So that is very important problem for a one dimension particle in one dimension. We calculate this easy form. Thank you very much.